Good morning, everyone. This is Susanto Maiti, your chemistry facilitator. Today, I will discuss the topic structure of atom. So, let's start. So, what is atom? Atom is the smallest particle of a chemical component that can exist. Atom contains three subatomic particles, that is electron, proton, and neutron. Electron is negatively charged, proton is positively charged, and neutron is electrically neutral. An atom overall is electrically neutral because it contains equal number of electron and proton. Electron is discovered by J.J. Thomson, proton is discovered by Rutherford, neutron is discovered by Chadwick. Now I will discuss the mass charge and net charge of these subatomic particles. Electron has a mass of 9.11 into 10 to the power minus 31 kg. As it is a very small value, that's why the mass of electron is taken as 0. And the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. And its overall or net charge is taken as minus 1. In case of proton, it has a mass of 1.6725 into 10 to the power minus 27 kg, and it has a charge of plus 1.6 into 10 to the power minus 19 coulomb. In this case, electron and proton has the same magnitude of charge, but they are opposite in sign. The net charge of proton is taken as plus 1. In case of neutron, it has no charge as it is electrically neutral, but it has a mass of 1.675 into 10 to the power minus 27 kg. Now I will discuss how these subatomic particles are distributed in an atom. So proton and neutron are residing in the center of the atom, that is called the nucleus, and electron residing or revolves around the nucleus in various cells or energy levels. I can explain it. It is nucleus. In nucleus, proton and neutron exist, and around nucleus, these are the energy orbitals, energy levels, and these are termed as K cell, L cell, M cell. And in this cell, electrons revolve. And it is nucleus. So, now I can explain atomic number and mass number. What is atomic number and mass number? Atomic number. Atomic number is the number of proton that can exist in an atom. It is represented by Z. As for example, nitrogen has atomic number 7. Nitrogen has atomic number 7. Oxygen has atomic number 8. That's it. So basically atomic number is equal to number of protons. And what is mass number? Mass number is equal to the total number of sum of protons and neutrons. So mass number is denoted by A. So mass number is equal to number of protons plus number of neutrons. And we also know that number of protons is equal to atomic number plus number of neutrons. So if we have to determine number of neutrons, then we have to subtract mass number from atomic number. That's it. Let's take an example. Nitrogen has mass number 14 and atomic number 7. So how many neutrons are there in nitrogen? So number of neutrons will be mass number minus atomic number 7, that is 7 neutrons present in nitrogen atom. In case of oxygen, it has mass number 16 and atomic number 8. So number of neutrons in this case will be 16 minus 8, that is 8. That's it. Now I will discuss how electrons are distributed in various energy levels or orbits. There are certain rules for this case. So first rule is the maximum number of electron that is present in an orbit or energy level is given by the formula 2n square, where n is energy level or orbit. In case of K cell, how many number of electron that is present? K cell 2n square. For K cell, the value of n will be 1. So 2 into 1 square, that is maximum 2 electron present in K cell. In case of L cell, 2n square, 2 into, for L cell the value of n will be 2 square, that is 8. In case of M cell, 2n square, 2 into, for in case of N cell the value of n will be 3 square, 18, and so on. Next rule next point to be remembered is the maximum number of electrons that can be accommodated in the outermost cell is 8. That is, outermost cell contain maximum of 8 electrons. And the third point is electrons are not accommodated in the given cell unless the inner cells are completely filled. So I mean to say that so electrons are filled in stepwise manner. Electrons are filled in stepwise manner. So let's take some example. Sodium atom has an atomic number of 11. So how 11 electrons are distributed in sodium atom? KLM. So we already know that K cell contain maximum of 2 electrons, L cell contain 8 electrons, and M cell contain maximum of 18 electrons. So how will you distribute 11 electrons in KLN? K cell 2, L 8, and one more remaining 1 electron. In case of aluminium, 13, 2, 8, 3. Calcium, 20, KLMN, 2, 8, 8, 2. That's the way the electronic distribution takes place. Now I will discuss the valency and valence electron. Valence electron are the number of electron that is present in the outermost orbit of an atom. Let's take an example. As in case of sodium atom, we already seen that The outermost shell is M shell and it contains one electron. So the number of valence electron in sodium atom is 1. And what is valency? What is valency? So to understand valency, we have to know first octet rule and doublet rule. So what octet rule says? Octet rule says that all the atoms have the tendency to contain, to accommodate 8 electrons in the outermost shell. Except in case of helium that contains 2 electrons in the K shell. So for this purpose, the atom may accept or reject electron, and the number of electron accepting or rejected, that is the valency of an atom. Overall, I can say that valency is the number of electrons accepted or rejected by an atom to accommodate, to accept, to accommodate 8 electrons in the outermost shell, except in case of helium atom that contain 2 electrons in K shell. So let's understand this with an example. In case of sodium atom, it contains 1 electron in the M shell. So to follow the octet rule, it lost 1 electron from M shell. For this purpose, and for what is the result? It contains 8 electron in the L shell, and that satisfies the octet rule. So its valency is 1. In case of oxygen atom, it has 8 electrons, Kl 2, 6. So as you can see that it has 6 electrons in the L shell. To follow octet rule, it accepts 2 electrons. It accepts 2 electrons in the L shell and its valency is 2. In case of aluminium, 13, 2, 8, 3. As you can see that aluminium has the outermost shell M shell that contains 3 electrons, and it's easy for aluminium to lose 3 electrons to follow the octet rule, and its valency will be 3. That's it. Now I can explain isotopes and isobars. What is isotopes? Isotopes are the atoms of same element that has same atomic number but different mass number. Let's take example. Hydrogen has 3 isotopes: H11, H21 and H31. All these hydrogen atoms have the same atomic number but different mass number, and these are isotopes to each other. It is called protium, and it is deuterium, and it is tritium. Another example is chlorine, 35, 17, 37, 17. These are isotopes to each other, and they contain same atomic number but different mass number. They are also isotope to each other. Isotopes have same chemical properties but different physical properties. So isotope, in case of chlorine atom, it has different mass number. It has different mass number. One chlorine atom has mass number 35 and another is 37. So question arises, what should we take the mass number of chlorine atom? In these cases, we have to take the average mass number. And to calculate average mass number, first of all, we must know the percentage of this isotope that can exist in nature. So this chlorine isotope exists the percentage of this chlorine isotope has exist in nature 75%, and it exists in nature around 25%. So its average mass will be 75 into its mass number 35 plus 25 into its mass number 37 divided by total 100, that is 35.5 U. That's a fractional value. This does not mean that any chlorine atom has a fractional mass of 35.5. It means that if we take a certain amount of chlorine atom and it will take two isotope, that is which has masses 35 and 37, then it has an average mass of 35.5. That's it. Next, I will explain what is isobars. So isobars are the atoms of different elements having same mass number but different atomic number. Same mass number but different atomic number. As for example, calcium 40, 20 and argon 40, 18. They are isobars to each other because they have same mass number but different atomic number. So that's it from my side. Thank you.